Chapter 8, Rational Functions. Section 8.1, Direct and Indirect or Inverse Variation. So we're going to look at three different kinds of variation: direct variation, inverse variation, and joint variation. And two variables are said to vary directly. Y varies directly with x if one variable changes directly with the other variable. So I don't really like to think about it as a formula, but more as a relationship between y and x. If they vary directly, then that means as x goes up or down, then y would go up or down. In other words, they would either grow or get smaller at the same rate with each other. And if we were to look at the relationship of this A is our constant of variation. In other words, that determines how they rise or fall with each other. And an example would be y equals 1/2 x, or y equals negative 3x. Inverse variation, y varies inversely with x. In other words, and again, in both these cases, a cannot be equal to 0. But in this case, as x gets larger, if we get bigger and bigger numbers for x, then that means y is going to get smaller, because we're going to be having a number divided by a bigger and bigger number. We're going to have a smaller piece of the pie each time. And again, if we were to solve this for our constant of variation, that means when we take x times y, we would get the same value each time. An example of this would be y equals 2 over x, or y equals 3 over 2x. And the third kind of variation is joint variation, and then that's when one quantity varies directly with the product of two or more quantities. So again, it's a kind of direct variation, but in this case we have a variable z, and that varies in relationship to x and y. So an example, z equals 3xy, or maybe a more useful example would be area equals 1/2 base times the height. In other words, the area changes when the height or the base changes. In all three of these cases, a is the constant of variation. In other words, that's the one value in the relationships that doesn't change. So let's take a look at some, and let's see if we can determine whether x and y show direct variation, inverse variation, or neither. So in this first example, it would be pretty easy to solve this for y. Multiplying both sides by 2, we get y equals 2x. In other words, as x goes up, y would go up. And so this is direct variation. In this second example, well, there's addition in this second example, so it shows neither direct or inverse variation. And in the third example, if we look at this, as y goes up, x would go down. So as one variable goes up, the other goes down, means it shows inverse variation. We should get in the habit and know how to solve this for y. And so to do that, if we multiply both sides by y to get the y out of the denominator, we get 5 equals x times y. And then dividing by x, we get y equals 5 over x. And so our constant of variation would be 5. Looking at this next example, again, pretty easy to solve this for y. Divide both sides by x. And we can see that this also is inverse variation. This last example, second to last example, multiply both sides by the 3 again to get the y by itself. Y equals 3x. As x goes up, y goes up, so it's direct variation. And this last one, we don't really have to multiply or do anything. You just have to realize that x over 2 is actually the same thing as 1/2 of x. And so that also is direct variation. Another kind of problem might be if they tell you that the variables x and y vary inversely, and then they tell you an example of what that relationship would look like. So if the variables x and y vary inversely, then that means y equals a over x. Well, we don't know what that constant of variation is, but we could find that because we have a relationship between x and y. So if we rewrite, plugging the 1/2 in for the y and the 6 in for the x, we can cross multiply and solve this, and we can find that a equals 3. So now we can actually write the relationship. We can write an equation that relates x and y. Y equals 3 over x. And now we need to find y when x equals 3. So we're just going to plug negative 3 in for x, and we can see that y equals negative 1. This next example is very similar. So if you think you got the hang of this, why don't you pause the video and try to go ahead and do it, and then come back or fast forward the video and see if you have the right answer, or just turn down the volume and do it at the same time. So we're told that it varies jointly, and so we have z equals axy. Again, we need to find what our constant of variation is, but we're given a relationship between z and x and y. So if we plug those values in, well, 4 times 3 is 12, so let's divide both sides by 12. We get that a equals 2. We can plug that in and write our equation, z equals 2xy. Finding z when x equals 2 and y equals 8, plugging those values in for x and y, we get that z equals 32. In the last example, we might be given different values as they relate. We need to determine whether they relate direct or inverse variation. So if we think about direct variation for a second, y equals a times x, well, we're given an x and a y, so let's go ahead and solve this for a, y over x, and so let's just take some of those values. 0.15 divided by 2,000, wow, gives us that. Make sure you change your number from your calculator into scientific notation. If we do the next one, well, those don't match, so it's not direct variation. Our a isn't the same, it's not constant. So now let's see if that represents inverse variation. Again, inverse variation is one goes up, the other goes down. So we need to find our a, which is the product of x and y. So let's go ahead and find that. 2,000 times 0.15, we get 300. 1,500 times 0.2. All right, so that must mean it is. But you need to make sure you check all the data values, because all it takes is one to blow the idea that it's inverse variation. So checking all of these values, they do come out to be 300, so it is inverse variation. The model is y equals a over x, so y equals, and we just solved all these for our a, so our a is 300 over x, and that's inverse variation. Alright, so if you have any questions, make sure you write them down, bring them to class. Come to class perhaps with some real examples of what inverse and direct variation occur. We'll start off with class with that.